Okay, so let's come to the second properties of uh, this cross product. So second is the distributive properties. So A cross B, A cross B plus C will give A cross B plus A cross C. What does that mean? That means that either we will add B and C and then take the cross product of A to that, or we can either take the cross product of A to B and then add the cross product of A to C. In both cases the result will be same. Okay, we can also prove these properties like this and the other the properties that I have mentioned in the previous part. These properties can also be proved with the tensor analysis that I will going to after the completing the electrodynamics, I will also start that series as well, or maybe I can start parallel to this. Okay, so now now come to the first properties. This is not the properties. So the first thing is that A cross B is not equal to B cross A. So how they are equal? Well, they are equal to the minus of B cross A. So exchanging the position of A to B and B to A will change the minus. Okay, so what does that mean? Well, let's analyze. So A cross B is the A B, okay, sine theta. This is the this is the multiplication of the two scalar quantity and the direction perpendicular direction vector n. Now here we will take the B A sine theta and the n cap. Okay, so these are the scalar quantity. We can interchange their position and nothing will happen. Okay, so this minus sign, so what we can say is that sine theta, okay, and this n will be written as the minus of n cap. So this minus sign will go into go with this n cap vector. Okay, so what n vector and n cap minus n cap vector are? Well, they are the same vector, the same unit vector, but represent they are pointed in opposite direction. So this n vector is pointing out of the plane, this green plane. So the minus n will represent a vector going the other side of this plane, pointing in the direction of plane. Okay, so that means A cross B will point to a point away from this plane, and B cross A will point inside this plane. Now, what this cross product actually physically represent? Well, the cross product actually represent the area formed by the parallelogram. Okay, so what is this parallelogram? So we have this vector A and the vector B. So if we transport this A over here and transport this B over here, then we will make a parallelogram with the angle theta, and same theta which is present over there, this formula, the same theta. So A cross B actually, its magnitude tells the magnitude of the area that is formed by this two parallelogram. By this parallelogram. Okay, and the n vector is the direction of this area. Okay, so we have either n cap direction, or we have minus n cap direction, representing that there are two possible possible direction of the area that is formed from A and B. Okay, one is this direction, I mean, okay, so let me represent. One is this direction and the other is this direction. So this is the physical representation of this cross product. Okay, now we will come to the the component form of the vector. Okay, so a vector A can be written in its component form. Okay, so vector can be written as Ax in the x cap direction plus B cap, I'm sorry, B y, no sorry, this is A y cap direction and A z cap direction. So if we are using the x, y and g coordinate, x, y, x cap, y cap and g cap direction, then this the project we break down this A vector into its component. So this will be its component. So what is this Ax, Ay and Az? So what we can do, we can take the dot product of A with the x cap vector, which is the unit vector representing the x direction. Then what we will get, Ax into x cap dot x cap plus Ay into y cap dot x cap plus Az into z cap dot x direction. So this will be 0, this will be 0, because because this x and y, this is orthogonal coordinate system. So their direction are their direction vector, the unit vector x cap, y cap and z cap are orthogonal. So and the dot product of two vector that are orthogonal will give the 0. So that's why these two terms will be 0. So here we will have Ax. Okay, so this is the Ax. So Ax is this vector. Now we can also write, okay, so we can also write I should write over here, we can also write A dot B by the formula vector magnitude of A, magnitude of x will be 1, okay, because it is a unit vector, so that will give a 1 into cos theta. Okay, so what is this theta? Theta is the let's write theta x. So theta x is the angle between this vector A. Okay, so let me draw this. So this is our axis, x, y and g, and let me draw this vector. This is the A vector, and this angle, the angle between A and x axis, is the theta x vector, theta x angle. Okay, and that will represent Ax. So Ax is nothing but the magnitude of A times cos theta of x. What Ax represent? Ax actually represent the projection of A vector to the x